Good morning, good afternoon, good evening. My name is Mark Champion. I'm your host and compere for the presentation. Thank you very much for joining us. Today, the webinar is going to be on how to manage and monitor large SQL Server estates. A lot of companies now that we're speaking to are growing their SQL Server estates, adding more servers, more complexity, and with that comes more challenges. So today, our agenda, we're going to look at two topics. So Jim Murphy, he's a consultant from SQL Watchmen. He's going to talk you through how to manage and monitor large SQL Server estates. And then Jake Sigrist is going to look at how to make your life easier, managing that quantity with SQL Monitor. And then there's the opportunity to ask questions. So in your little GoToWebinar thing, there should be a bit for questions. If you want to pop your questions there, we'll answer them at the end. So if you've got a question, just jot it down and then we'll answer it at the end. Anything that we don't answer at the end, we can get in contact you directly and then you can go through it. So without further ado, I'm going to transfer across to Jim. He's going to give you a view of how to physically do all this horrible stuff. All right, Jim, the floor is yours.
All right, thanks, Mark. Appreciate that. Okay, so my name is Jim Murphy, CEO of SQL Watchmen, and we're going to be talking about a whole lot of issues with large estates in SQL Server. Okay. So just a brief bit about me. I've been using SQL Server since 6.0 back in 1997, and I've supported both large and small estates and large and small systems. Been a friend of Redgate for many years, a national speaker at various tech events across the country. Just a bit about SQL Watchmen. We're a tech company based in Austin, Texas, and we do remote fractional DBA. We're well familiar with compliance-related issues, HIPAA and whatnot. We have some healthcare customers. We do DBA services, performance tuning, disaster recovery, SQL programming, SSIS, SSRS, things like that, cloud migration. Okay, now we'll get past all of that, all of the plug. Okay, so today we're just going to be scratching the surface, really. There's so much to talk about, and as we were working up this content, wow, it's just such a huge topic, and there are real big issues in dealing with large estates of SQL Server. So we're just going to be handling just a few of these issues, some of the bigger issues. So if we don't cover an issue that you're seeing, it's probably because we just don't have the time, really. We are going to be breaking this down into two pieces. We have managing and also monitoring large estates of SQL servers. And we're going to be discussing some DIY options, things you can do on your own without monitoring tools that you can accomplish the same thing. We'll kind of contrast that with, there's some tools that other vendors have out there that might make things a little bit easier, and then you can make the choice which way you want to go. So we're briefly going to talk about pitfalls and avoiding them. We'll discuss some tips and tricks and all kinds of noise and how do we deal with alerting issues, and then a conclusion. That'll be the first part of the webinar before we turn it over to the Redgate folks. Okay, so let's start off with pitfalls that DBA see with large estates. We very much see different and unique issues as compared to people with a server or two. One of those would be with alerts. How do we deal with SQL agent being stopped? I mean, if SQL agent is stopped, we don't get alerts. We don't get emails. We don't get jobs running. If we have our own jobs that check and balance and scan for stuff, make sure everything's healthy, well, those aren't running either. And when you have one server, it's easier to deal with. But when you have a couple hundred servers, wow, that really turns into quite a big problem. So a few DIY solutions. We could use PowerShell, a lot of PowerShell scripting. I'm sure you guys are familiar with PowerShell. If not, you should absolutely look into it. It's a great way to better manage large estates of SQL Server. So that does need a little bit of programming. It's kind of easy, simple scripting programming, but it does end up getting more and more complex the more you get into it, and you have scripts all over the place to do stuff. Another DIY option would be the central server to check all the other instances. but they need monitoring on that central server to make sure that that also doesn't go down. Kind of a fail-safe situation. We're going to talk more about alerts a little bit later. Okay, another key aspect we need is a dashboard. When we're dealing with a single SQL server, we don't need a dashboard. We can look at the metrics on that SQL server and we get a good idea of what's going on. If we have 10 independent SQL servers, it's a little bit of a chore remoting into each one of them and looking at it. But if we have 100 servers or a couple hundred servers or 1,000 servers, wow, that's a lot. And that's really rough for us to be able to manage. Right now we're managing about 1,800 or so instances, and you can't do that without some kind of a dashboarding tool. For example, we need to identify out of the, let's say you have 100 servers, the 97 that you don't care about because they're green and healthy, and the 3 that you really do need to drop what you're doing and go get your coffee first, of course. It's always a prerequisite, and then go fix those 3. So a couple DIY solutions for making a dashboarding solution would be maybe SSRS or Power BI. Some people use Grafana, it's kind of a dashboarding tool, open source. So those are cool, but as you start to think this through a little bit, it's like, well, wait a minute, we need not only some SSRS or Power BI reports or Tableau or whatever, but now we need drill downs. Actually, we need a lot of reports. Well, now wait a minute, if I have a couple hundred servers, I mean, those reports need a data source, not 100 data sources. So are we going to have clones of, hundreds and hundreds of reports to tap in all these instances? It's just unmanageable. So really what we'd want to do is aggregate all that data from those couple hundred servers into one central repository spot, and then we can report off of that. Wow, but that's starting to sound like kind of a bigger problem. In fact, pulling all that data, sweeping it, now we got to prune the data on each of the localized instances so it doesn't fill up the disk space there, and also prune our repository. Oh, it's turning into a full-blown data warehouse project, or at least an ODS project. So let's just think about this. We have 300 servers, and we're collecting wait stat information, I don't know, every minute, every 5 minutes, every, whatever. Perfmon school, we're going to look at that in a little bit. But there are a lot of metrics in Perfmon, thousands and thousands, probably tens of thousands actually, of metrics in Perfmon for everything from the OS to the SQL Server. And capturing that, some of those Perfmon counters should be captured at 1 minute intervals, others maybe 15 seconds, others maybe 5 minutes or 10 minutes. So capturing all that data is a huge amount of data to deal with. SP Who is Active from Adam Mechanic, excellent script. I encourage you to use that. SP Blitz from Brent Ozar, excellent script. I encourage you to look into those. So setting those up on jobs, setting those up to collect data and throw that into a table regularly turns into data overload. So that's the first problem, is trying to collect the data. There's really 4 components to making our own project to get all this working with our reporting. The second part is sweeping all this data to a central repository. How are we going to get that from 300 different servers, all that data into one repository? So now it's sounding like either a whole bunch of SSIS packages or one complicated SSIS package that handles errors really well in case there's a server offline or something like that. Pruning local repository data. Wow, it's kind of getting bigger and bigger. Okay, the third step is we have to interpret those results. Just because we have data, I mean, what does this stuff mean? If page life expectancy is 450, is that okay? If our I/O latency is 15 milliseconds, is that a problem? Maybe it's not a problem. Maybe it's a problem on one server but not on another. If we see 2,000 locks per second, is that abnormal? I mean, I don't know. It happens a few times here and there. Is that really something that people are complaining about or blocking for 2-3 seconds at a time? All these are normal things that a DBA has to deal with. But when you have hundreds of SQL servers, how do you know where to look and where not to look? Which servers to ignore? Which servers to pay attention to? And if you're collecting all that data, that's a great start. But there needs to be something that triggers or prompts somebody to say, hey, we're seeing an issue, look over here and dig deeper into this problem over here. I/O latency is a specific problem. For example, if our I/O latency jumps up to 50 milliseconds, is that a problem? For some systems, yes. For other systems, no. But what if that happens at 8 p.m. at night, and that happens to be when the backups kick off? Well, sure, you can expect your I/O latency to be increased. Your I/O subsystem getting slammed. That's kind of normal for backups. So it might be normal for that time of day. So just collecting the data is not enough. We need a way to interpret, kind of like having a rules engine on top of that to figure out, is this normal? How does it compare to this time yesterday or this time last month for month-end processing or something like that? And then the fourth major piece of this project is making the data accessible. I'm talking a web browser here. If it requires VPN and then remote desktop, maybe running a thick Windows app built in C# or something like that, or a vendor tool even. Some of the monitoring tools out there from some vendors are thick client window apps. And when you try to run those solutions like that, wow, I mean, sure, it only takes a few minutes for VPN and a few minutes for a remote desktop and a few minutes to fire up a big desktop app and start looking at things. But we're still talking a 15-minute round trip in order to get all the way in and all the way back out and look at what you need to look at in order to find out that, I don't know, there's a good chance that maybe that issue didn't need action. And again, we're going to talk about alerting a little bit more later. So we absolutely want to make sure that we can easily get to the data, web browser, somebody can use it from an iPad or an iPhone or something like that, so they can consume that data rapidly and figure out, is this actionable? Do I need to fire up my laptop and get into the system and fix something or not? Can I handle it tomorrow? Okay, backups. Are they working? Okay, so what if the job is disabled? Backups don't work, or if the agent is stopped. We briefly talked about that. What if the job succeeds, but the job success option is set incorrectly? Or maybe if the job fails, but it's set incorrectly. Or what if the job succeeds, but there's no BAK file? We had one company call us. They had they lost some data. It was pretty unfortunate. They had a developer that forgot their where clause. You probably heard this one before. We hear it about every 6 months, it seems. A developer forgot the where clause, deleted all the rows in a table, called us because they were looking around for the backups. They couldn't find them. They had a job running. They were making sure that the job was running and it was succeeding, but they couldn't locate the backup. So we get in, we start looking around at how they have their system set up, and we figure out, oh, wow, you know, apparently sometime back they moved their backups from local to remote storage on a network drive, but the permissions were not set up right. So the job settings were set incorrectly, even though it wasn't actually making that backup file. It was reporting a success, and there's no backup to be found at all. So yeah, they lost some data. They had some backups from dev and things like that from a couple weeks before, but that was a data loss event, and it's something that can easily be prevented if only they knew and they were able to keep up on this. So just because there's a BAK file, or rather just because the backup job succeeds, does not mean there's a BAK file. And even if there's a BAK file or transaction log TRN files, that doesn't mean that the chain isn't broken. So these things need to be tested. And okay, so let's talk about some DIY solutions about this. So well, yeah, see, that's the first solution. Maybe a little hope and prayer. Hopefully that's not the extent of our solutions. Okay, so one thing we can do is have a checklist. And with that checklist, we can have manual verification with the DBA and have them remote in or verify jobs are succeeding versus failing, make sure that, you know, or if they're sending email notifications, making sure that the notifications are being received, but also making sure they feast their eyes on the backup files, make sure they're all good. Of course, that's not a very good use of time and money. You have to staff up with some bunch of juniors to deal with the large estate, and that's really not going to be good, and also error prone. Another option is PowerShell. You can write some PowerShell coding in order to go into all these different databases and start verifying these options. That's not quite as simple as it sounds. LSN numbers and things like that, it can kind of spin out of control pretty quickly. But that's some options. So another issue is disk space. A lot of people say, oh, gee, if you know, we'll set a trigger up when the disk is 80% full, and that'll just let somebody know and it won't be a problem. Well, that's not always the case. We have one customer, that has, let me see, an AWS estate. They have probably about 730 servers, Windows various servers. About 50 of those are SQL servers. And some of those are very high end. They've got very expensive, massive VMs. They have like 4 terabyte EBS 20,000 IOP guaranteed drives. They're very expensive. They're like $1,000 a month for just the drives, and they have like 5 of them on a couple different instances. And their database isn't even large enough to fit on one of those drives. It's got to be split across a couple of those different drives. So if you do the math on that and you think, gee, a 4 terabyte drive, 20% free or 80% full, that's still 800 gig free, right? 800 gig is not exactly low disk space. So we can't treat that the same as other systems and think, oh, 80% full, let an alert, somebody needs to look at it. With 800 gig free, that's so much space that that alert really doesn't make a whole lot of sense. So it needs to be adjusted and handled a little bit differently. And when we deal with failing jobs and long-running jobs, that just complexifies the issue. And we'll talk a little bit more about that in just a sec. Okay, so that was some of the common pitfalls. Let's talk about some tips and tricks and what we can do about some of these issues. Oh man, if only I had a button like that on my laptop. Let me look. Nope, still not there. Okay, so management and compliance. So change compliance and change control, that's a real issue. We want to make sure that our enterprise is set up consistently and following best practices. But what does consistent mean? Some things like making sure XP command shell is disabled or removed. Yeah, that's good. We might be able to apply that for all or almost all of our servers. We might need to leave it on for one vendor server or something like that. But things like max stop gets a little more complicated because that might have to be set differently based on the hardware that it's sitting on. So 4 might be the right value on this server, 8 might be the right value on that server. Or if it's OLTP versus reporting, then that can make a huge difference on that. But what we can all agree on is auto shrink and auto close. Those should always be disabled. I don't even know why there are options there. Microsoft. So we absolutely want to make sure that our whole enterprise is set up with our, whatever your corporate best practices are, we need to make sure that all the systems are consistent. We also need to make sure that other people can't change those changes, or if they do make changes or introduce new hardware to the mix, everything follows the company standard and everything matches up perfectly, and if it becomes out of compliance because somebody else did it besides you, that you can identify that and bring it back into compliance. Okay, so DIY solutions. Well, we're back to PowerShell. PowerShell is a great tool, but I mean, we've been talking about PowerShell kind of a lot, and there's already now a whole lot of scripts that we're going to be using PowerShell for. So PowerShell is your friend, but I hope you enjoy programming, because that's what PowerShell is, programming. Another option is policy-based management. That's really cool. I'm sure some of you, maybe a lot of you, are using that. PBM, you can Google PBM or Central Management Server, CMS. If you Google those, you find some really cool stuff. I'll just show it super briefly here. If you can use registered servers to add in a whole bunch of servers, put your whole estate in there, or groupings of your estate, and you can right-click and say, I want to evaluate policies. And then with the policies, you can choose your source, pick files, and when you browse the files, Microsoft builds in, they already have a whole bunch of these policy files, and you can add your own, they're XML files. So with that, we can just look and say, okay, database auto close and auto shrink, we want to make sure those are all set to false on my whole entire estate. And when you run that, you'll see that database auto close is successfully in compliance in your whole estate, whereas database auto shrink, you got a problem. And if you look at all of your servers and all of your databases on those servers, you find a single database on a single server that's out of compliance. But at least now you can go and identify that and go adjust that. So that can help you manage a larger estate a little bit better. There's a lot more to that tool. Hopefully this gives you the idea. If you're already using it, great. If for those that may not be using it, this is, hopefully you're loving this. Okay, now let's briefly talk about performance. The spinny thing. Okay, so a lot of the time we find out that our databases are the foundation of our entire application, even our whole corporate stack. And if everything is slow, oh man, we can have a boss that hopefully doesn't look like this guy and an employee that hopefully doesn't look like this girl. That, yeah, we don't want that at all. So we need to regularly work on performance and make sure our servers are working in tip-top shape. A first step for that is with wait stats. With wait stats, a wait stat is SQL Server tracking every single thing that it's doing, whether it's idle or waiting on a resource or something like that. I'm not going to go into it much more than that, but there's a great document there. We'll make sure the slides are available, SlideShare or something like that, so you can go read that doc. It's an old doc on weights and queues from Microsoft, but it's a really good read. And then essentially what we need to do is figure out, based on the wait stats, which resources are the bottleneck, and then find the queries that are consuming those resources. Okay, so the way we do that is with perfmon. We're not going to really cover these. Again, the slides will be available, and these are just a few of the perfmon counters. There are so many more to record. Things not to monitor is the old kind of, it's not a myth really, but PLE being less than 300 being a problem. That was maybe valid 10, 15 years ago when it was first kind of documented, but it doesn't really apply anymore. Disk queue length, that also doesn't apply in this day and age of SANs. I mean, how many disks, how many spindles are in the disk pool that's driving that LUN that you have? Who knows? So disk queue length may not be a good value to monitor anymore. With perfmon, by default, it saves everything to a file, which is less useful for you. Now you got to use SSIS or some other tool to get it into SQL, or you can change the log format to SQL, hook that to a DSN, and jam that right into SQL Server. But still, you have a bunch of perfmon metrics inside SQL Server. Okay, and then finally, once you figure those bits out and you know where your constraints are, now we got to identify which queries are the problem. I was going to post the query here, but it's kind of long, so I'm not. But if you go to the SQL Watchmen page, the contact us, and just let me know that you want the worst query. I'll go ahead and email that to you, and I'll show you that in just a sec. Okay, let's get a demo going. Okay, so here we have a system. Let's go ahead and apply a workload to it. So I have hey, look, PowerShell, and it's running a random workload. Don't worry about some of the errors. That's just, it's running all kinds of different select statements and whatnot in random order, and some of those require temp tables and objects and things like that, which may not be there. Okay, so we have a workload going. Now we want to figure out what is happening on the SQL Server. So to measure this, we want to use perfmon, or performance monitor. Performance monitor, we'll load that up. And by default, it aggregates all of the CPU cores into one metric. I'm not going to change that right now, but just to give you a brief idea, you can add more counters, and just under the processor section, wow, there's a huge, which one of these is processor? There's a huge amount of them. Another great metric is under physical disk. But again, which one's latency? And I mean, so there's plenty of information out there, and I'm sure you guys are using this right now today, and that's good. For those of you who may not be using perfmon, now you know that there's a great way to add a bunch of metrics. One of the metrics we're going to add right now is one under your instance and then SQL statistics. And there's one called batch requests per second. That really measures the throughput of your SQL Server, how many queries are coming through per second. So when we look at that, turn on the highlighter, we'll see that our CPU is maxed out at about 100%, and our batch requests per second are around 21. So this kind of forms our baseline so that we can get a feel for what is normal on our system. So now we want to identify which queries are using up most of the CPU or I/O or whatever. So here's a query I'll email to you. When you run that, it's currently ordered by I/O. You can order by CPU, whichever. But you can see that, wow, out of all of these, if we focus on this one query, then that's going to give us a big return on investment. And that query happens to be a somewhat complicated query with a pivot and things like that. You have your execution plan. You can look at all this and begin your engineering in order to tune that query and reduce the impact massively. Okay, so that's just a brief way of how manually we identify and get to tuning our system and improving performance. Now, a super brief note about perfmon. If we're collecting perfmon data, so I collected a little bit of perfmon data just to see how big this is going to end up being. And it ends up being about 500,000 rows, but I only collected for a couple hours. This is about, what, 5 hours or so? Something like that. So if you add that up to 24 hours, we're talking just about 2 million rows or so being collected every 24 hours. That's a lot of data, and that really needs something to react to it. I mean, you can see some of the data it's great perfmon data saved to a table. You have your nice counter values and things like that, which will help you build an alerting engine and an interpretation engine to figure out, is that a problem or not? But you can see that that is kind of a project. Okay, so trying to figure this stuff out on one instance is, well, it's hard enough, but when you have 100 different instances and trying to diagnose performance and deal with that, it's not easy. It's not an easy challenge. Okay, one pro tip is look at the frequency that you're collecting data. The average over 1 minute might look very different than an average over an hour. Sometimes you might have, you might see spikes because you're collecting everything every minute, and your SAN admin sees no spikes because he's collecting everything once an hour, averages for the hour. We had a huge hedge fund company call us. They had several DBAs doing all the right stuff. The SAN admin was saying that there was no problem with the IO system. DBAs were saying it looks like it's the IO system. And what we figured out when we started digging into it was that their frequency was different. And once the SAN admin knew that and zoomed in a little bit, whoops, he saw the issue with the IO system. Okay, so some of the DIY solutions. Wow, are we going to have an email once a day from 1,000 servers? That's 1,000 emails with their top 10 worst queries. Oh, that would be kind of a mess. Furthermore, how do we deal with baselines? And you know, are the queries heavier than they were 2 weeks ago, or are they running longer? What does longer mean? Is that 50% longer than usual, or 200% longer than usual? And deadlocks and failed logins. How do you deal with failed logins? Oh man, you know, because 1 or 2 in a minute is not a problem, but 100 in a minute is absolutely an issue. And so you might find some help with some performance dashboard reports, kind of primitive, built into SQL Server that Microsoft creates, or maybe SCOM, but SCOM, the System Center Operations Manager, oh man, it's really rough and clunky. It's not really a great solution. Okay, so now we're going to talk briefly about what's all this noise, how can we avoid it. We're talking about alerting. Hey, look, an old school iPhone. I remember when they used to look like that. I think the upgraded models came with 2 cups and a wire. Okay, does your email box look like this? Hopefully not. Let me see, thousands of emails popping in with a variety of servers involved and a variety of issues. So maybe you absolutely need to care about a severity 20. It's high enough, but maybe a severity 20 event 31 might be something you don't really care about. Some jobs failed. Are these critical jobs or not? So we end up getting bombarded with all kinds of alerts, and if we use primitive alerting built into SQL Server and have those all set up to bombard us, oh man, that gets real overwhelming real quick, and that creates alert fatigue, which means that DBAs start to make an Outlook rule and throw it into a folder and then pretty much forget about it. Now you have really critical and important alerts not being acted on. It's a big problem. So to help with this, alerts must be actionable. If an alert is not actionable, then there needs to be a way to suppress the alert, whether that's custom coding on your part, or maybe you can simply disable the alert, or using some kind of a service. So one of the services that we use is OpsGenie or PagerDuty. You might have heard of those before. They're pretty cool. You can get all of your alerts, go into those services. You pay those services by the month. And they kind of dedupe, you know, failed logins. If there's only 3, no big deal. But if it hits a threshold within a certain period of time, then it'll create a ticket in Jira, or we use Redmine or whatever for a ticketing system. So those can absolutely help reduce the amount of noise so that your DBAs don't create Outlook rules and then miss stuff. Okay. And in conclusion, we just want to talk about that in review that managing lots of SQL servers is pretty tough. There are some DIY options using policy-based management, central management server that we saw, a lot of PowerShell. So there's ways to do this, but it's kind of a lot of work. And monitoring a large estate of SQL Server is also very difficult. In fact, it starts turning into a big, giant product, really. I mean, it's hard to be a good DBA when you find yourself as a software product architect, a developer, and then a never-ending supporter. It will never be done, and you'll always be struggling to keep up with implementing the next version of SQL, the next feature, and all that stuff. Believe me, I know. The reason I know is because I've built systems like this before, and over the several decades I've been doing this. So it's not a small, not a trivial issue. Now, for some of you, this is going to be the right choice to DIY it, build your own infrastructure. But probably for most of you, it's probably not going to make a whole lot of sense to build all that infrastructure and complication in order to monitor your estate. So it really comes down to a build versus buy decision. And if you don't have a budget, then you can spend hours and hours and hours and hours coding, but that's an effective way to do it. Then you end up with a hodgepodge of tech, various pieces of tool, a little bit of PowerShell here, T-SQL over there, a little bit of C# sprinkled in, which means more risk of issues and failing, and it's never going to be done. The other option is to just write a check and be done with it. I mean, I'm in the same boat as you guys, dealing with how do we manage and monitor huge estates of SQL Server, and I have the same exact issues, and it comes down to, do we have more time or do we have more money? And I know money's always scarce, but to be honest, I don't know too many DBAs that have plenty of time to kick back and Facebook all day long. Usually we're very, very busy, so just write a check and be done with it. Okay. So with that, hopefully that gave you a brief overview and kind of allowed you to peer into some of the complications of handling this the DIY way. So with that, I want to thank you for attending, and at this point, we'll turn this back over to Mark.
Thanks, Jim. That's been great. As I said at the start, if you've got any questions for Jim, if you type them into the little box, and I'm sure he'll be willing to answer any random questions you have. I'm now going to pass you over to Jake, and Jake's going to go through a bit about SQL Monitor and how some of the issues and problems that Jim was discussing earlier, how SQL Monitor can actually make that a lot easier to manage. Jake.
Awesome. Thanks, Mark. And can you guys see my screen okay and hear me okay? Okay. Okay, perfect. So I'll just go from here, guys. So again, as Mark mentioned, I'm going to show you guys a potential, and I think a really potentially strong solution for helping to rectify a lot of the issues and problems that Jim mentioned previously as it relates to monitoring large SQL Server estates. So really briefly here at the beginning, just to do a quick introduction. So again, my name is Jake Sigrist. You might notice that I don't have an English accent like my colleague across the pond, Mark. Redgate is a UK-based company, but I actually operate outside of our Los Angeles-based office here in California on the West Coast, and I'm an account executive here. And yes, to be full disclosure, I am a salesman, so I obviously, have my Redgate hat firmly on top of my head, but I have many years, of experience working with DBAs, talking about these specific issues. I've worked at Redgate for a number of years, and I've gotten to speak with lots of different data teams, lots of different operations and infrastructures teams, whether it's at small companies looking after 1, 2, 5, 10 servers, as well as very large enterprises looking after 50, 100, 500, and even 1,000 plus servers. So without further ado, I want you guys all to brace yourselves here a bit, because I am going to get into a live demo of the tool here over the next 15 or 20 minutes. And again, what that tool is called is SQL Monitor. It's very appropriately named. And this is Redgate's solution for database performance monitoring and alerting. And so what I'm going to be walking you guys through here is just a really high-level overview of how we tackle, again, many of the different issues that Jim mentioned in his presentation before. We're going to scratch on the surface on a lot of different things. You guys are definitely going to get a good understanding of what the tool is and get a really good feel for the tool over the next 15 or 20 minutes. But there's definitely still more that I'm going to leave out. This is something that you guys want to take a closer look at. Definitely get in contact with us and let us know. So what we're looking at right now here is the user interface of the tool. Before I actually deep dive into things a bit more, I want to square things off a little bit in the beginning. So in terms of the architecture of the tool, what you guys would actually be installing and interacting with, you might notice that I'm here in my Chrome browser right now, and SQL Monitor does have a web-based user interface. So any interaction you're going to be having with the tool is going to be done through your browser, and I think this is really great because it offers a high degree of flexibility in terms of actually interacting with your monitoring solution, your dashboards, etc. You don't have to you don't have to install any sort of clunky installer. And the tool, Redgate's tool, is agentless as well. So you don't actually need to install any sort of software, configure anything on the servers that you're looking to monitor as well. So in terms of the installation package that comes with SQL Monitor, it's really just 3 key components. It's the web server, usually an IIS Express web server that comes with the installation package. There's the monitoring service, which is a Windows service that's actually going to be collecting the data from your servers. And then obviously there's going to be a SQL Server repository that's going to be collecting and housing the data that's going to be displayed here on the UI. So right now we are looking at the main page of SQL Monitor. As we work through the tool, I want you guys to pay close attention to this kind of black bar up here. Those 4 different tabs, we've got the Overviews, Alerts, Analysis, Reports tab. That is going to kind of be the workflow that we go through right now in terms of walking through the tool. So we're going to work left to right for the most part. So right now we're looking at the Overviews tab. And so right now I have my SQL Monitor pointed to roughly, if not exactly, 100 instances of SQL Server. And with anytime you're looking at a large state, Jim mentioned this a couple times, it's really difficult to really be capturing and understanding the data for something that's as large as 100 instances, right? So big question that I want all you guys out there to think about as you're looking through this, as we're walking through SQL Monitor, is how I am being presented with the most important and the most pertinent information to me about my large estate to where I can actually take considered and specific action on the things that require my attention right now. As Jim mentioned too, you guys, DBAs, looking after large estates, you don't have a ton of time on your hands. So it's really, really crucial to understand what is the best use of time. And in many ways, SQL Monitor is automating the process of gathering that data, automating the process of presenting it to you, and then really it's giving you the opportunity to only do the most impactful part of your jobs, which is to take action on your servers. And so right now we're looking at this 100 server view here on the dashboard. Because of large estates, it's kind of difficult to see this all on one page. We actually give the option to consolidate this view here. So you get a nice, a much more consolidated, better at-a-glance view of what the status is and what the health is of my SQL Server estate at any given time. Each one of these cards represents a specific SQL instance. And so as I highlight each one of these, I'm actually presented with a couple tidbits of information. You can see there's some weight stats, some CPU information, as well as some disk I/O there. Just some really high-level stuff that's good at a glance. You can notice here, too, that we've got these set up into a couple different server groups. This is totally configurable, so you can name these server groups as you want and put as many different servers in them as you want as well. Right now, we've just got it set up for, I believe, 50 production instances as well as 50 staging instances. So I've got this ordered right now by name, but a lot of times, again, in the spirit of making sure you're understanding the most important things at a glance, I'm going to order these by severity to make sure that I've got the most critical things bubbling up to the surface so I know what to take action on. We've got 3 severity levels here. There's a critical level, there's a warning level, which is that amber color, and then we have a healthy level, which is green. So when I order this by severity, all of the amber and critical level issues on any of these instances are going to float up to the top. So what I'm going to do now is, and remember, I'm still in the Overviews tab here, so I'm actually going to drill into one of these instance cards here. And as I do that, I would say that this is really where most of the meat and potatoes of this of a tool should be done, which is doing some of the drill down and giving you consolidated information in the form of an intuitive dashboard so you can actually, again, make decisions quickly and make sure you have a positive impact on your environment. So there's lots of information down here that we'll walk you guys through here in a sec, but I do want to talk about this graph up here a little bit more in detail. So right below here, you can see that we've got these 4 metrics in blue, purple, green, and orange. I call these kind of the big 4. These are the big 4 heavy-hitting metrics that anytime I talk to a DBA, no matter what environment they're looking at, large or small, if they're saying to themselves, okay, there's a problem in the server, I want to know what's going on, any DBA I talk to, the first thing, or one of the first things I'm going to look at is the performance of those 4 different metrics. So we've got these displayed down here for you guys. And then we've also got this this graph up here, this time graph up here as well. So right now we're looking at this for today, which is Wednesday 29th, which 9:40 Pacific time, which is where I am. And we're looking at this for the last 24 hours, so we can see that nice graph displayed there. If we want to look at it for different time intervals, for 6, 12, 2 days, 3 days, we can do that as well. And then I can make and then the graph adjusts there. Interesting thing to note, and I think it's one of the more important things on this tab here, is that we've got this nice window display here on this graph. And so what this is actually going to do is, as I drag this across the graph, let's say this spiking here, spiking of activity is interesting to me. Once I do that, you guys will notice that this data down here is actually going to refactor to mimic or to actually display in more detail this window that I set up here for this spiking. And so I can move it across like this. And then also, if I want to get a more granular view, I can actually contract the window like so. And then again, you'll see that this data down here is going to refactor as well. And so as I actually go through this down through the data here below, this is all going to be changed and reflect the time window that I set up here. So anytime I make a change up here, again, if I move that across, the information below here is going to be updated. And that's really nice, right? Because again, Jim mentioned this before, you're collecting all this data, you're having it displayed on a dashboard for you, but the crucial thing is you can't be looking at your servers at all times, right? You can't be running a script post-problem. That's not really going to give you a ton of good impactful information. You really want to know what's going on when that problem occurs. And so that's why having a tool that's going to be actually collecting the historical data like SQL Monitor and then be able to go backtrack, highlight on specific points in that data history, and then take a closer look is going to have a massive impact and time savings on you guys being able to diagnose and understand problems and also just understanding the general health of your environments. So again, as we work down here, we give you some information on the top 10 queries. There's a table here. I can sort this out by duration, CPU time, physical reads, logical reads, etc. I can also look at the top 10 weights and do some sorting there as well. Cool thing about the top 10 queries is that if I actually take a look at a query here and actually click on it, I can check out the query plan, I actually get the script there, and then I can also take a closer look at the query plan within the tool as well, which is a really nice at-a-glance view. And you can see, a matter of getting from where I was to now should only take a DBA, a matter of a few seconds. And then we've also added a new beta feature into the tool as well, which is query history. So any one of these queries that I select here, it's actually going to give me an understanding of how that query was performing for a variety of different metrics over a certain time frame. Right now, it's for the window range that I have up there, but I can also look at CPU time, logical reads, and a few other metrics. And then as we scroll down here, again, it's a lot of high-level stuff. So you got your high-level SQL Server metrics, your latches and locks information, host machine metrics, some information about blocking processes, etc. Also, you can drill into the specific databases too. Okay, so now I'm going to take you guys into this alert section here. As part of any good monitoring solution, actually, it should be a base level for any monitoring solution, period, whether you're building it or you're looking for the market to provide you one. You need to be set up with good alerts, and making sure that these alerts are not only telling you the information that you need to know about specific problems, but actually making sure these alerts are configurable and actionable, so you're not just dealing with a bunch of noise. Jim showed that inbox earlier of all the noise that he's dealing with, but making sure that these alerts are actually important are going to really be important to you guys doing the best you can for monitoring, especially for larger states, right? More servers usually means more problems, which usually means more alerts. So it's crucial for you guys to have something in place that's only giving you the most important information. So right now we're looking at the most up-to-date, this is essentially an alert inbox for things that have been coming in on these servers. You can see a couple example alerts here for blocking processes, deadlocks, etc. But we actually have a variety of different alerts. You can actually see a good list here. Some of the standard alerts that are in the tool. We've got a nice list here of the basic SQL Server alerts. We do monitor availability groups, so we have some alerts down there for that, as well as alerts for your host machine. And so as I quickly just drill into one of these specific alerts, I like taking a look at this deadlock alert. It provides some cool information as it relates to specific deadlock. So right now in the deadlock alert, you're provided with information about that specific deadlock. You can see who the winner was. You can see who the loser was. And then with each one of the alerts that you click into with SQL Monitor, you're also given a snapshot of the performance of the server at that given time. So again, this gray bar here on these graphs represents time when that alert was actually raised. And you can get into some other information here about your SQL Server, system processes, etc. Now again, this is an alert inbox, and a lot of times for larger states, there's not just one DBA, there's multiple DBAs. The nice thing about having a tool like this is that it allows you to do a lot more communication, so you can actually clear alerts. You can actually add comments to alerts and then share those around amongst your team and make sure that they're being properly handled. And then again, to make sure that all your alerts are actually actionable, we do allow you, near full configuration for what the thresholds are for these alerts. So if I wanted to customize a setting for a specific deadlock alert, I can set whether I want that to be a low alert, a medium alert, or a high alert. And then for lots of other different alerts, like let's say a long-running query alert, you can actually set the threshold for what each one of these levels mean to you. Maybe a medium level alert for a long-running query is 90 seconds for one DBA in one company, but maybe that needs to be 5 minutes for another DBA at another company. That's all configurable as well. Okay, so moving along here, this is something that I think is crucial to SQL Monitor itself, and I think it's one of the key components that really separates us as truly the tool for enterprises and for large estates, and that's really done here on this analysis graph. So as you can see here, this is kind of an expanded view of that time graph that we saw on the specific instances in the Overviews tab. So it's going to look pretty familiar. Right now, we're looking at the machine stop processor time for this specific instance. We can essentially graph any and all metrics that the tool is collecting on this analysis graph as well. So for whatever reason, we wanted to take a look at the transaction metrics for the database. We can graph that there. We can look at the disk use percentage, etc. Right now, we're just going to stick with machine processor time. And so I know, again, a lot of these conversations that have DBAs, one of the main, most critical things that they want to know is, especially with the largest state, they have all this information that's being transacted. They have all this performance information for all these servers. And one of the most critical things they want to know is what is healthy behavior and what is unhealthy behavior, right? You don't necessarily know that inherently. You need to collect information, collect data over a period of time, and get a good understanding of, okay, this is what's healthy for this metric on this server, and this is what's healthy for this metric on this server, etc. And SQL Monitor is really going to help expedite that process, and we do that through this baselining feature on the Analysis tab. So right now we're looking at this for the last 2 hours. Again, if we want to expand that time range, we can do so. I'm going to keep it at last 1 hour, let's say. Actually, no, let's get some more variety of data. Let's do the last 6 hours. Okay. And again, I can update this for, right now this is the last 6 hours from now, but I can update this for a week ago, 2 weeks ago, etc. And so what I'm going to do is I'm going to click this compare baseline button here. And so now what I'm looking at is 6 hours prior to the 6 hours that are graphed here. So now we've got to do the last 12 hours essentially, and that prior 6 hours is graphed here in this sort of lighter blue shade behind that. But that doesn't really give me enough information to really understand, what is normal, what is not. So I actually have the ability to extend this baseline out to of iterations up to 10. So right now it's on 7. If we move that up to 10, now we're getting a really good understanding of, okay, what does normal performance look like for this server as it relates to machine processor time? A lot of times for some metrics on some busier servers, this gets pretty crazy. So we do have the ability to make that into a regions view. And that way, again, you get a quicker at-a-glance view of what's happening on your server. And also, this helps give you that quick at-a-glance view of, hey, is this performance healthy or is this performance unhealthy? This is something I need to take a look at. One of the beauties of, one of the great things of the tool being web-based is that I can actually, let's say there's something interesting on this graph and I need to show it to my DBA manager, I need to show it to my boss. I can actually just take that URL, send it over to him, and once he clicks into it, he's actually going to be looking at the same exact information that I had grabbed from the URL. So it's really kind of a nice way of having a monitoring tool not only collect and serve you data, but also becomes this communication tool to where you can disseminate information across teams as well. And then really quickly, we're going to hit here on this last tab here. It's the reporting feature of SQL Monitor. It's actually something that's pretty new, pretty recent that the devs had been working on and had put into the tool over the last few months, earlier this year. And so I don't have many reports in here right now for this demo, but you can see here in the example report, the way we actually present this reporting to you guys is through this tile setup. So each one of these tiles represents a specific, I guess, a more drilled down report, and then we consolidate those together into a larger report that you guys see here. Lots of flexibility in terms of the data sets that you're going to actually be able to create a tile for. So we see here that we can actually create a tile for any and all of the metrics that is available to us in the analysis tab as well, for any of the servers. And then we can display, how large we want that tile to be, et cetera, name it, obviously. And then we also offer a few different options for specific summary tiles too. So I can put in a tile in there for the longest running queries, for the instances with the lowest uptime, a few others here. I know a big report that I talk to a lot of our clients about is actually the fastest filling disks, because they want to get a good understanding of, okay, how quickly is this, is my disk space, how quickly is my storage filling up, and can I be alerted to when it's hitting a capacity that's dangerous? That's definitely something that you're able to do with the reports, the reporting feature in the tool as well. And we actually have the ability to have these reports emailed out too on a routinely basis. So I can name it, put in the specific recipients, say when I want that emailed out to them, and then boom, you're done. You're good to go. So I know we're running kind of low on time here. I know we only have a few minutes left, but that for the most part is my surface level overview of the tool, how it helps you guys look after large estates. If you have any questions, let us know. And at this point, I'll go ahead and hand it back over to Mark.
Thanks, Jake. That's great. I've got a few questions here from you guys, and feel free to type anything else in that you've got. One quick one I'm going to answer was a question from Macro. Why is there a gap in monitoring at 2 a.m.? That's because this is it's a demo system that we use, and it goes off and it goes on. And so when there's nothing to monitor, because the box has been turned off, you're not going to get any data. So what's probably might be a more accurate demo that you can have a look at, if you go to monitor.redgate.com, which is the live monitoring of SQL Server Central, which is a website that we run, you can see the precise data from that. And so you have a look at that, and it will show absolutely everything. And this is real data from a real server running a real application. So you can have a play around with this. Jake's showing you got the URL at the top. If you go there, you can play around with your heart's content, and don't worry, you can't break anything. Right, I've got a couple of questions here. First one is from Kamal, and it says, how many instances can you actually run on SQL Monitor? How many SQL servers can you actually monitor? So maybe that might be for Jake.
Yeah. No, that's a great question, Kamal. So the tool itself, I've talked to various different clients that have SQL Monitor up and running on a few hundred servers. So the scale and the capacity that this tool can handle is definitely, at that large scale. Really, a lot of that is going to depend on how busy those specific servers that you're monitoring actually are. So we do have some white papers that give a good baseline in terms of what performance you can expect and what likely could be, maybe your max for the number of servers in the tool. But To this date, I have not talked to a client that has a large enough environment that the tool hasn't been able to work for, especially with some of the more newer releases and performance improvements we put in the tool. So, yeah.
Okay, cool. Question from John here. It says, how big does my SQL Server estate need to be before I need to look at a third-party tool? So maybe that's a question for Jim?
Yeah, okay, that's a good question, John. Well, okay, so it really gets down to convenience and being able to really manage this. And if you have one server, you can do it the do-it-yourself way without a monitoring solution. It just takes a lot more time looking at all this stuff, and it still needs a whole bunch more code in order to collect all this stuff, even on a single server. So when you have 10 or you have 100 servers, you absolutely need a tool. 10, you absolutely need a tool. Even at one, honestly, my professional opinion is to still have a monitoring tool even on one, unless you already have all those scripts that you've been dragging around for years and you can do it yourself already.
Cool. Got a question from a guy called Pete, and it says, with the alerts in a native SQL Server, can you prioritize them at all? So probably you, Jim, as well.
Yeah, with SQL alerts, the DIY way, trying to prioritize them, not really. I mean, if you use something like a PagerDuty or OpsGenie or some service like that, then yes, you can increase their severity or decrease their severity once you apply the rules and determine if it's noise or not. But normal general SQL Server alerts, I mean, you just set it up primitively in SQL Server saying, for example, severity 18, just send me an email. Severity 22, text me and wake me up. That sort of a thing, and that's all it is. And every time it hits that alert, it's going to perform that that simple action.
Cool. Question from Joe. Can we access the schema within the SQL Monitor repository to mine data from it? I don't know if Jake, you want to do it, or whether...
Yeah. So the answer to that question, the short answer is yes. So you can actually go into the repository itself and access the data that the tool is collecting. And I do believe, and someone can correct me if I'm wrong, but we do actually maybe that's not the case, so I won't say that specifically. But it is, because of the way that repository is set up and because of the complexity of all the data that it's collecting, it's doing a heck of a big job in terms of, making sure that it's collecting the data correctly and displaying it to you correctly. So my best advice on that is, if this is something that you're interested in, and that's, as you look through the tool and work with us, and that's a question that you guys have, we can bring in one of our engineers and help, essentially help you explore that database and see if there's anything in there that you want to pull natively yourself without the use of the tool, if that makes sense.
Cool, thanks. Question from Paul. How much roughly would it cost to license 100 servers for a SQL Monitor?
Yeah, Paul, that's a great question. So we're pretty transparent with our pricing. You can actually go to our website if you want right now, look at SQL Monitor and see what the pricing of the tool is. We do license per server. So we've got standard pricing for a couple servers, 5 or more servers, there's a volume discounting. 10 or more servers, there's volume discounting. I will say this, if you're in the range of 20, 30, 50, 100 plus servers, that's definitely something that we're able to work with you guys on in terms of finding a pricing model that makes sense in terms of your environment. So I would say for you, with 100 servers, definitely reach out to us. We can have a conversation, and then we'll figure out what's going to make sense there.
Cool, thanks. Just time for one more, I think. Does this tool work with always-on instances, and how does this tool behave when instance fails over to another instance? That's from Jack.
So in terms of always-on, monitoring always-on availability groups is definitely something that's within the tool. You can see here that on these, this is the live demo that you guys actually have availability to out there. It's on our website. You can see here that we've got the AG tag here, so that means these two instances are part of the availability group. So obviously I can click into them standard there. But if I navigate to the specific availability group, This is something that we didn't see in our demo prior. You can actually see that we give some specific AG metrics. We can actually see the primary replica, availability replicas, et cetera, et cetera. In terms of the way the tool handles and behaves when it's failing over from one instance to another, that's not too much of a complex question, but it does take a bit more detail, something that needs to be dug into. So maybe once we get off the call here, maybe that's something that we can follow up with you on, and then kind of gives you some more detail there. That's something that I'm happy to do myself as well.
Great. I think we've run out of time, guys, so thank you very much for attending. Really appreciate it. But if you've got any questions that we didn't get around to answering, Jim and Jake's contact details are on the screen now. So Jim is SQL Watchmen, and you can email them info@sqlwatchmen.com. Jake or any of the Redgate team you want to speak to, sqlmonitor@red-gate.com. We've recorded the webinars, and I'm going to be emailing it around to you guys in a couple of days' time. But thank you very much for joining us, and hope to see you at another webinar soon. Cheers, guys. Bye.